Good afternoon, everybody. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haliyad. In the previous session, we were discussing about difference equations. What do you mean by difference equation? And how to apply the Z transforms as well as the inverse Z transforms in order to find the solution of this difference equation. We are finding the solution of the difference equation. It is same as how we used to find the solution of the differential equations. We used to find the solution of ordinary and partial differential equation. Same concept is applied to these difference equations, where difference equations are the difference between two successive terms of unknown terms in the given equation. So equation of the difference between the two unknown terms. So such a group of equation we will call it as difference equations, and we are finding the solution of the difference equation. Now what we do is we have already solved two questions. Let's discuss few questions in today's class. How many possible we'll discuss. Then if remaining we'll do it in tomorrow's class. Then also from tomorrow onwards we'll begin with our revision, because with the difference equation is the last part which was pending, which I'm doing right now. So we can start with the equation. What is that? Revision class. So however, those who have learned this before, you will be more thorough, and those who have come new now, lateral entry students, for them also it's going to be a revision. So the concepts are more clear. Okay, so let's begin with today's class. Solve by using Z transforms. Today's question, solve by using Z transforms. Given an equation yn plus 1 plus 1 by 4 times yn, that is equal to 1 by 4 whole power n, with the condition n greater than or equal to 0, y naught value is 0. So this is the question. We need to solve this equation using Z transforms with certain conditions. So first thing what we need to do is we know what is Z transform of yn plus 1. See, we have learnt in general what is Z transform of un plus 1. Z transform of un plus 1 is z into u bar of z minus u naught, and Z transform of un is what it is? It is u bar of z. And also Z transform of un plus 2 is z square into u bar of z minus u naught minus u1 into z power minus 1. So these things we need to remember in order to solve the difference equations. So given this equation, first concept what we do is we apply Z transform on each of these terms. So applying Z transforms, what we get? Z transform of yn plus 1 plus 1 by 4 into Z transform of yn, that is equal to Z transform of 1 by 4 whole power n. So this is what we do. We apply Z transform on both sides. Next, we know Z transform of yn plus 1. It is same as Z transform of un plus 1. Variable is u is changed to y. So you have to change the variable and write as it is. So what is Z transform of un plus 1? Here it is. Z into u bar of z minus u naught. So Z transform of yn plus 1 will be z into y bar of z minus y naught. Variable u is changed to y naught. Okay, afterwards, what do we have afterwards? It's 1 by 4 into Z transform of un is u bar of z. So Z transform of yn is y bar of z. That is equal to, what is this? We have Z transform of k power n. What is Z transform of k power n? Anybody remember? What is Z transform of k power n? These things you should not forget. That too I have done this in
Z by Z minus K.
Yeah, z by z minus k. So that transform of k power n is z by z minus k. Here in place of k we have 1 by 4. So z transform of 1 by 4 whole power n is z divided by z minus 1 by 4. See k is 1 by 4. So z transform of k power n is z by z minus k. K here is 1 by 4. So this is what we get. Next step what we do is we collect the coefficients of y bar of z. What are the coefficients of y bar of z? So y bar of z coefficient here it is z. Then here also we have the coefficient of y bar of z, that is 1 by 4. So we get y bar of z into z plus 1 by 4. This is after collecting the coefficients of y bar of z. And in the question it is given value of y naught. What it is? 0. So here if you substitute y naught to be 0, it will be 0. What is remaining? Y bar of z into z plus 1 by 4 equal to z divided by z minus 1 by 4. That's expression on the right hand side. Next from this we find what is y bar of z. Take this term to the denominator because we have to find what is y bar of z. So let's take this term to the other side. It will be z divided by z minus 1 by 4 into z plus 1 by 4. Z minus 1 by 4 which is already there. When you take this term to the other side, it will be z plus 1 by 4 in the denominator term. Now again, denominator is a product of linear factors. So we can solve this using the method of partial fractions. And in the method of partial fractions, first thing what we do is u bar of z, suppose if it is given, we find u bar of z divided by z. So here the variable is y bar of z. So let's find y bar of z divided by z. So when you divide by z on both sides, here also if you divide by z, here it is divided by z, here also divide by z, this z and z get cancelled. What will remain? 1 divided by z minus 1 by 4 into z plus 1 by 4. This is what we get the set of partial fractions. After we apply partial fractions, what do we denominator the linear factors? We can write them as a divided by z minus 1 by 4 plus b divided by z plus 1 by 4. Okay, I hope this is clear because we have a denominator factors, that's why it's a divided by z minus 1 by 4 plus b divided by z plus 1 by 4. Now what do? We take this term. To this term we multiply the entire equation by z minus 1 by 4 into z plus 1 by 4. Multiply everywhere by the term. So when you multiply the entire term over here, denominator and numerator get cancels, 1 remains. When you multiply over here, z minus 1 by 4 and z minus 1 by 4 get cancels, a into z plus 1 by 4 remains, plus to the second term if you multiply over here, denominator z plus 1 by 4 is there, that get cancelled, so z minus 1 by 4 remains. This term I need to multiply here and here and here. So whatever term which is there in the denominator gets cancelled and the remaining terms we will have. I hope this is clear. Anybody has any doubt? Anybody has any doubt? The same thing whatever we discuss. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. Next, now we need to find the values of A and B. For that, what we do? If you want to find A, make the coefficient of B 0. How can we make B 0? Coefficient of B has to be made 0. Z minus 1 by 4 equal to 0. Therefore, Z equal to what? 1 by 4. Put Z equal to 1 by 4. We get 1 equal to A into Z value is 1 by 4 plus 1 by 4 plus B into, when you put 1 by 4 minus 1 by 4. Z as 1 by 4. This term will be 0. So what is this? A into 1 by 4 plus 1 by 4 is 2 by 4. 2 by 4 is what? Half. So what is the value of A? It is 2.
2, ma'am.
1 by 2. A into 1 by 2 equal to 1. So A value is 2. Next, I have to make a 0 now because I need to find the value of b. In order to make a 0, we have to make the coefficient of a 0. So when z plus 1 by 4 is 0, what shall we put z value as? When can we make z plus 1 by 4 as 0? What value of z we should put?
Minus 1 by 4, ma'am.
Minus 1 by 4. So when you put z equal to minus 1 by 4, 1 equal to a into minus 1 by 4 plus 1 by 4 plus b into z value is minus 1 by 4 minus 1 by 4. This term will be 0. Here we will have 1 equal to b into minus 2 by 4 because minus 1 by 4 minus 1 by 4 is minus 2 by 4. 2 ones are 2 twos are. So value of b is minus 2. Because b into minus 1 by 2 equal to 1, therefore b value is minus 2. Is it okay? Now substitute the value of a and b in this expression. Here it is, take this as star, substitute the value of a and b in this one. So what do we get? From start, y bar of z divided by z, that is equal to 1 divided by z minus 1 by 4 into z plus 1 by 4, that is equal to a. A is 2 divided by 2 divided by z minus 1 by 4 plus b value is minus 2 divided by z plus 1 by 4. This is what we get it. Now this is y bar of z by z. What is this? Y bar of z by z. So what is y bar of z? You multiply z to this expression. You multiply by z because this is y bar of z divided by z. If you want z, multiply both sides by z. So it will be 2 into z divided by z minus 1 by 4 minus 2 into z divided by z plus 1 by 4. In order to find the solution, apply inverse z transform because we need to find the inverse z transform. Then only we will get the solution, which is yn. Z inverse of y bar of z. So what do we get? Z inverse of y bar of z 2 times z inverse z transform of z by z minus 1 by 4 minus 2 into inverse z transform of z by z. This z plus 1 by 4 I can write it as z minus of minus 1 by 4. Is it okay everyone? Because we have the formula only for inverse z transform of inverse z transform of z by z minus k. Denominator should be minus k. It is k power n. But here we have z plus 1 by 4. Z plus 1 by 4 can be written as z minus of minus 1 by 4 where k is minus 1 by 4. So what happens when you apply inverse z transform? Inverse z transform of y bar of z is yn because see this is from the definition of z transform. Z transform of yn is y bar of z. So inverse z transform of y bar of z will be yn. So inverse z transform of y bar of z is yn 2 times. What is inverse z transform of z by z minus 1 by 4? Same concept you apply. Inverse z transform of z minus z by z divided by z minus k is k power n. So same problem. Z inverse z transform of z by z minus 1 by 4 where k is 1 by 4. That's why this is 1 by 4 power n. This will be 1 by 4 power n minus 2 into here k is what? Minus 1 by 4. So inverse z transform of z by z minus k is k power n where k here is minus 1 by 4. So it is minus 1 by 4 whole power n. So this is the required solution. Anybody wants me to ask any doubt or if any step is not clear, ask me. Anybody has any doubt?
No, ma'am.
Please ask if anybody else has any doubt. Not in class, you can ask me after the class as well. It's not a problem. No doubt? Then we'll move on to the next one. Discuss the next question. Solve the difference equation. Solve the difference equation yn plus 2 plus 6 times yn plus 1 plus 9 times yn equals 2 power n with y naught equal to y1 equal to 0 using z transforms. Okay, solve the difference equation yn plus 2 plus 6 times yn plus 1 plus 9 times yn equal to 2 power n with the conditions where y0 and y1 value is given to be 0. So first thing what we need to do is we have the equation yn plus 2 plus 6 times yn plus 1 plus 9 times yn equal to 2 power n. To this equation apply z transform. So when you apply z transform, it will be z transform of yn plus 2 plus 6 times z transform of yn plus 1 plus 9 times z transform of yn, that is equal to z transform of 2 power n. Now then we have the formula for z transform of yn plus 2 etc. What is this z transform of yn plus 2? I'll write down the formula first. Z transform of yn plus 2 is z square into u bar of z minus u naught minus u1 into z power minus 1. Then z transform of yn plus 2 is z into, sorry, here variable is y. Okay, you have to change the variable as well. If it is un plus 2, then it is u. If it is y, then it is, you have to change according to the variable. So z transform of yn plus 1 is z into y bar of z minus y naught. Then one more, z transform of yn is y bar of z. So these things you need to remember. Now let's substitute one by one these things in the equation. This is the equation 1. So from 1, when you substitute all these things in 1, first one is z transform of yn plus 2. What is z transform of yn plus 2? Z square into y bar of z minus y naught minus y1 into z power minus 1 plus 6 times z transform of yn plus 1. Yn plus 1 is here, that is z into y bar of z minus y naught. So this is z transform of yn plus 1 plus 9 times z transform of yn is y bar of z, that is equal to, what is z transform of 2 power n? Repeat this in almost every class. Z transform of k power n is z by z minus k. So z transform of 2 power n is z divided by z minus 2. Is it okay?
Yes, ma'am.
Okay, done. Now let's rearrange that so that we get a coefficient of y bar z only. So collect the coefficients of y bar of z. Y bar of z coefficient is z square. Then here also we have y bar of z. Y bar of z coefficient is z into 6. So it is plus 6z. Then here also we have y bar of z coefficient is 9. So this is what we get when we collect the coefficient of y bar of z. Y bar of z into z square, so z square. Y bar of z into 6z, so 6z. Then y bar of z into 9, so plus 9. So this is the coefficient of y bar of z. And in the question it is given that both y0 and y1 are 0. See here it is given both y0 and yn are 0, y1 are 0. So even substitute that. What happens when you substitute y0 and yn to be 0? See, this is y0 is 0, y1 is also 0, here also y0 is also 0. So all the terms get cancelled, only this thing remains. Y bar of z into z square plus 6z plus 9, that is equal to z divided by z minus 2. This is what we get it. Now what is y bar of z from this? What is y bar of z? That will be z divided by z minus 2 into, take this to the other side. How you can write this as z square plus 6z plus 9. When you look into this equation, what expression do you get in mind? How can you write in simplified form z square plus 6z plus 9? What is z square plus 6z plus 9?
Z plus 3 into Z plus 3.
Correct. That is a plus b the whole square, where a is z, b is 3. It is z plus 3 the whole square, isn't it? Z plus 3 the whole square. What is a z plus 3 the whole square? Z square plus 3 square, which is 9, plus 2ab, 2 into z into 3. So 3 2s are 6z. So it is z plus 3 the whole square. Z square plus 6z plus 9 is what? Z plus 3 the whole square. So again, now this also you can solve by the method of partial fractions, because in the denominator we have terms which are linear factors. So how to solve this now? Here there is a power of 2. So there is a slight change in how do you split it. First thing what we do is, this is y bar of z. So how do we split this? How we can do this? We can either find y bar of z divided by z. Can we do that? Y bar of z divided by z. What is y bar of z divided by z? 1 divided by z minus 2 into z minus 3 the whole square. Now how do you split it? You have a power of 2. So first term is find power of 1, a divided by z minus 2 plus. Now what do you do? Here you have z minus 3 the whole square. So how do you write it? It is b divided by z minus 3 plus c divided by z minus 3 the whole square. This is how you write it.
Z plus 3, ma'am.
Yeah, correct. Z plus 3. Z plus 3 the whole square. This is how you write it when you have a square term in the denominator. Okay, if when the power is 1, you just write it a divided by z minus 2. But here the power is 2. So how do we write it? It's b divided by z plus 3 plus c divided by z plus 3 the whole square. Suppose if you have a cube term over here, then it will be d divided by z plus 3 whole cube. Z plus 3, Z plus 3 square, Z plus 3 whole cube. Okay, this is for your understanding purpose I am telling. Now it is 2, so it will be b divided by Z plus 3 plus c divided by Z plus 3 the whole square. Now let's simplify this. What do we do for that? We multiply the entire expression by Z minus 2 into Z plus 3 the whole square. Multiply everywhere, here and here. So when you multiply over here, denominator and numerator are same, every term get cancelled, so 1 remains. Multiply over here, when you multiply in the denominator z minus 2 is there, so z minus 2 get cancelled, so what remains? A into z plus 3 the whole square plus b into, when you multiply the expression over here, denominator z plus 3 is there, so one of the z plus 3 get cancels, what remains? Z minus 2 into z plus 3. So the third expression, when you multiply over here, denominator z plus 3 whole square is there, so z plus 3 whole square get cancels, only z minus 2 remains, c into z minus 2. Is it clear, everybody? Anybody has any doubt in this method of partial fractions? Anybody has any doubt? Those who have learned Laplace transform, they will find it easier because we have discussed more in detail while solving Laplace transform. Still, if anybody has any doubt, please ask me. This entire thing we have to multiply. That's what we did. Everywhere we need to multiply. And some terms which are there in the denominator get cancelled. So whatever remaining, we will write down. Now we will have to find the coefficients A, B and C. First thing, what do we do? Put. First, if I put z equal to 2, this term will be 0, this also will be 0. Let's put z equal to 2. 1 equal to a into z value is 2 plus 3 the whole square. Here see, z minus 2, z is 2, 2 minus 2, so this term will become 0. Even if I put z equal to 2, 2 minus 2, 0, so b and c both term will be 0. 3 plus 2, 5, 5 square is 25. This implies what is the value of a? It is 1 divided by 25 because 1 equal to A into 25. 3 plus 2, 5 square is 25. So A value is 1 by 25. Next, what shall we do? What value we shall put? Put Z equal to what?
-3, ma'am.
Correct. If you put -3 over here, this term will become 0. See, if you put -3, A will become 0. Even here in the case of B, here also if you put Z as -3, this term also will become 0. So we get the value of C. So put Z equal to -3. 1 equals, this first term will be 0, second term also will be 0. C into -3 minus 2. -3 minus 2 is -5. So what is the value of C? -1 by 5. Because C into -5 we get. So value of C is -1 by 5. Now, what option which is pending for us in order to find the value of B is we cannot make any other value 0 so that we get the value of B. It is not possible. So in such case what we do is we equate the coefficient of Z square on both sides. Equating the coefficient of Z square on both sides. Coefficient of Z square on both sides. Coefficient of Z square on both sides. What happens when we equate the coefficient of Z square on both sides in this expression? From start, here C into Z minus 2, you won't get any coefficient of Z square, but here you get Z into Z. When you multiply these two, Z into Z, so Z square, coefficient of Z square is B. Here also A plus B the whole square, it is Z plus 3 the whole square, so Z square plus 6Z plus 9, so coefficient of Z square will be A. And here on the left hand side there is only a constant term, there is no expression as such Z square. That's why the coefficient of Z square will be 0. Here coefficient of Z square is A. In this case coefficient of Z square is B. So we get A plus B equal to 0. If A plus B equal to 0, what is the value of B? Minus A. A is what? 1 by 25. So B will be minus 1 by 25. Anybody has any doubt in this? Please ask. We equate the coefficient of Z square. On the left hand side there is no coefficient of Z square, so it is 0. Here when you take it, it is A plus B the whole square. So when you expand you get Z square. So coefficient of Z square will be A. Here also when you multiply these two terms, Z into Z, Z square, coefficient of Z square is B. Here we do not have any Z square term. So we get C also as 0. A plus B equal to 0. A equal to B equal to what? We have to find B because A and C we have already found out. So B is minus A is 1 by 25, so B will be minus 1 by 25. So this is the coefficient. A, B and C we have found out. Now substitute all these things over here in this equation to substitute A, B, C values. So what do we get? Y bar of Z divided by Z, that is equal to 1 divided by Z minus 2, Z minus 2 into Z plus 3 the whole square, that is equal to A divided by Z minus 2. What is A? 1 by 25 into Z minus 2. So it is here, it is A by Z minus 2, this is done, plus B divided by Z plus 3. B value is what? Minus 1 by 25, minus 1 by 25 into 1 by Z plus 3. Then third term C is minus 1 by 5 into 1 by Z plus 3 the whole square. Here in equation 2 you substitute what is A, what is B, what is C, and the denominator rest all remain same thing. So this is Y bar of Z divided by Z. So what will be Y bar of Z? Multiply by Z on both sides. To this entire expression we multiply by Z in order to get Y bar of Z, because this was Y bar of Z divided by Z. So when you multiply by Z, what do we get? 1 by 25 into Z divided by Z minus 2 minus 1 by 25 into Z by Z plus 3 minus 1 by 5 into Z by Z plus 3 the whole square. You multiply by Z everywhere. Now next, what do we get when we multiply by Z everywhere? Next step what is remaining is to find the inverse Z transform. Inverse Z transform of y bar of Z is 1 by 25 into inverse Z transform of Z by Z minus 2. Minus 1 by 25 into inverse Z transform of Z by Z plus 3 is there. How can we write it as? We can write it as Z minus of minus 3. Remember this, Z plus 3 is there. We have the formula for inverse Z transform of Z by Z minus K. So in order to write it in that form, Z plus 3, we split this as Z minus of minus 3. Minus 1 by 5 into, what about this term? Tell me this term. Z plus 3 whole square is there. We have the formula for inverse Z transform of Kz divided by Z minus K the whole square. What is this? Is it correct? Anybody remember this? Inverse Z transform of Kz divided by Z minus K whole square. Anybody remember this?
Yes, ma'am.
What
K
is
power
it?
n into n.
Okay, this is k power n into n because we do not have any other formula to apply over here. See, it is inverse Z transform of Z divided by Z plus 3 the whole square. There is no other formula to apply other than this one. It is, but here what is the problem? It is kz divided by z minus k. Z plus 3 you can write it as, how z plus 3 can be written it as z minus of minus 3. So our k is what now? Minus 3. In order to apply this formula, what I should do? I should have k over here in the numerator. But here there is no term k in the numerator. That's why we multiply and divide by minus 3. What do? We multiply and divide by minus 3. Am I correct, everybody? We multiply by minus 3, also we divide by minus 3. Then what do we have over here? Inverse Z transform of Z by Z minus of minus 3 whole square. This is what we get it. Z plus 3 whole square, we can write it as Z minus of minus 3 whole square. Now this is 1 by 25 into inverse Z transform of Z by Z minus 2. What is inverse Z transform of Z by Z minus K? It is K power n. Here K is 2, so it is 2 power n. Minus 1 by 25 into inverse Z transform of Z by Z minus of minus 3. K is minus 3, so it will be minus 3 power n. Next, what happens over here? Minus of minus, it will be plus. We have over here 5 3s are 15. 1 by 15 into this minus 3 I can take inside and I can write it as inverse Z transform of minus 3Z divided by Z minus of minus 3 whole square. Am I correct? Because there is only one formula. When square is there in the denominator, it is inverse Z transform of kz minus kz divided by z minus k whole square. It is k power n into n. When the denominator you have a square term. So but k is what? Minus 3 it is, because it is z plus 3 the whole square. So z minus of minus 3 we have to make it. K is minus 3. That's why we need to multiply by minus 3 here, because I need to write it as kz. Otherwise I cannot apply this formula. That's why I write it as I multiply and divide by minus 3. Then here this whatever we have divided, we will write it as 1 by 15, and here minus 3 I take it inside. So it will become minus 3z divided by z minus of minus 3 whole square. So when I apply over here, what do we get? 1 by 25 into 2 power n minus 1 by 25 into minus 3 power n. Here what it will happen? 1 by 15 into what is this? Apply this formula now. The inverse Z transform of kz by z minus k whole square is k power n into n. What is k? Minus 3. So minus 3 power n into n. Is it okay, everyone? Anybody has any doubt, or anybody wants me to repeat?
No, ma'am.
Anybody any doubt? Practice this question. So you should be able to understand what to multiply and what not. Okay. We want k, it's not any random number I have multiplied and divide over here. I have multiplied and divide by k. K is over here, minus 3. That's why we have multiplied and divided by minus 3, so that it gets converted to this form. So we can apply the formula and it will be k power n into n. So this is the required solution. You can take 1 by 5 common from each of these terms and you can write the answer, or you can leave it as it is. So is it clear, everyone?
Yes, ma'am.
Okay, let's discuss the next question. Find the response of the system. Find the response of the system yn plus 2 minus 4 times yn plus 1 plus 3 times yn equal to un with y0 equal to 0, y1 equal to 1 and un equal to 1 and un equal to 1 for n equal to 0, 1, 2, 3, etc. by Z transforms. By Z transforms. Read this question, everyone. So what is it said? We need to find the response of the system yn plus 2 minus 4 times yn plus 1 plus 3 times yn equal to un with the conditions y0 and y0 is 0, y1 equal to 1 and un equal to 1 for all the positive integers using the method of Z transforms. So given an equation yn plus 2, here it is the given equation. First step what we do is we apply the Z transforms with the condition un equal to 1. So we shall put un equal to 1 over here. So applying Z transforms, we get Z transform of yn plus 2 minus Z transform of 4 I can take outside, yn plus 1 plus 3 into Z transform of yn equal to 1 because un equal to 1. It is given in the question. It will be what now? When you apply Z transform, it will be Z transform of 1. Because we are applying after substitution of what is un equal to 1, un equal to 1. So and then we are applying the Z transforms on both sides. So on the right hand side it will be Z transform of 1. Is it correct, everyone? I have applied Z transform on the entire equation where un equal to what? Un value is 1. So it will be Z transform of 1. Is it okay? Yes or no? Okay. Anybody any doubt? Yeah, let's continue. So what do we get over here? Z transform of yn plus 2. It is z square into y bar of z minus y0 minus y1 into z power minus 1 minus 4 times z into z transform of yn plus 1 is z into y bar of z minus y0 plus 3 times z transform of yn is y bar of z, that is equal to z transform of 1. What is z transform of 1? What is z transform of 1?
Z by Z minus 1.
Z divided by Z minus 1. What others are doing? Only Shilpa keeps answering every time. What is the problem with others? You need to work out every day. So now we shall combine the coefficient of y bar of z. What do we get when we combine the coefficient of y bar of z? Here we have z square. Then here we have coefficient of y bar of z, z into minus 4. So it is minus 4z. Here also coefficient of y bar of z is 3 plus 3. This is what we get. Then we know the constants here. Y0 is 0, so Y0 is 0. Y1 value is 1. So it will be minus 1 into z power minus 1. Am I correct? Minus 1 into z power minus 1. So it will be minus z power minus 1 into z square. Here outside z square is there. So into z square. Z square into z power minus 1. What it will be? Z power 2 into z power minus 1. It will be z power 1. Y0 is 0. So rest all terms we have written, that is equal to z divided by z minus 1. Now we need what is y bar of z. In order to find that, if we take this to the other side, it will be z plus, this will be plus z by z minus 2. Then is it okay everyone? It is z minus 1, sorry. It is z minus 1. When we take minus z to the other side, it will be plus z, correct? It will be plus z. Then what else we have over here? We'll write it once again. Y bar of z into z square minus 4z plus 3. That minus z, you take it to the other side, it will be plus z. Then here which was already there, z divided by z minus 1. This is what we get. Now can we write z square minus 4z plus 3 as a product of linear factors? Find the roots and check. Can we write them as a product? Can we write this equation as a product of linear factors? Z square minus 4z plus 3. You take the multiple of 3 as minus 3 minus 1. Minus 3 minus 1 is plus 3. Minus 3 minus 1 is minus 4. So you can write it as z square minus 3z minus z plus 3. Am I correct? Minus 4z, you split it as minus 3z minus z. Minus 3 into minus 1 is plus 3. Okay, multiple of 3. So if I take z outside from these terms, z minus 3 remains. Similarly from these terms, if I take minus 1 outside, z minus 3 remains. So total z minus 1 into z minus 3. So you can write z square minus 4z plus 3 as z minus 1 into z minus 3. So what will be y bar of z? It will be z minus 1 into z minus 3. That is equal to z plus z by z minus 1. Now we want y bar of z. For that what we do? Take this term to the right hand side. We get y bar of z. So when it is divided, it will be z divided by z minus 1 into z minus 3. Similarly, you have to divide to this term as well. Z minus 1 is already there. Here there is one more z minus 1. So it will be z minus 3 into z minus 1 whole square. You take this entire term to the other side. It will come to the denominator. So z minus 1 into z minus 1, z minus 1 whole square. Then one more z minus 3. Is this clear to everybody? Is this clear?
Yes, ma'am.
Okay. Now I write this as P of z. I write this as P of z plus Q of z. This as P of z and this as Q of z. I write y bar of z as P of z plus Q of z. Then next what we do, we find the inverse Laplace transform of each of these terms, P of z and Q of z. Okay, we find the inverse Laplace transform of each of these terms. So first I'll take P of z. What is P of z? It is z divided by z minus 1 into z minus 3. I take P of z as z divided by z minus 1 into z minus 3. Then by partial fractions method, we will find what is P of z divided by z. P of z divided by z is 1 divided by z minus 1 into z minus 3, which is nothing but a divided by z minus 1 plus b divided by z minus 3. This is by splitting, because we want to find the constants a and b by the method of partial fractions. So we have this equation, multiply by this denominator to the entire equation. So when you multiply by z minus 1 into z minus 3. So when we multiply here, the terms denominator and numerator are same, everything get cancels, 1 remains, 1 equal to. When you multiply over here, z minus 1 get cancels, so a into z minus 3 remains, plus b into. When you multiply over here, z minus 3 get cancels, z minus 1 remains. So this is what we get it after we multiply entire term by this denominator. Now we shall find a and b. What do we do in order to find a and b? I want to find a, make the coefficient of b 0. So it is what, z minus 1. How can we make z minus 1 0? When you put z equal to 1, z minus 1 will be 0. So we shall put z equal to 1. So when I put z equal to 1 in this expression, it will be 1 equal to a into 1 minus 3 plus b into 1 minus 1, which is 0. So what is the value of a? A into minus 2 equal to 1. So a value is minus 1 by 2. Similarly, I want to find b over here. In order to find b, let's make the coefficient of a 0. How can we make a 0? If I put z equal to 3, 3 minus 3, it will be 0. That's why we put z equal to 3. So when we put z equal to 3, 1 equals a into 3 minus 3, which is 0, plus b into 3 minus 1. 3 minus 1 is 2. This will be 0. So 1 equal to 2b. This implies b equal to plus half. So this is what we get. Substitute this over here in p of here. So p of z divided by z equal to 1 divided by z minus 1 into z minus 3, which is nothing but a by z minus 1. A is minus half. Then b by z minus 3. B is plus half. So this is what we get. So this is what, this is p of z divided by z. So let's find p of z. What is p of z? Multiply by z everywhere. So it's minus half into z by z minus 1 plus half into z by z minus 3, because we have to find p of z. This was p of z by z. That's why we multiply by z on both sides. Next step, find the inverse z transform on both sides. So inverse z transform of p of z equal to minus half into inverse z transform of z by z minus 1 plus half times inverse z transform of z by z minus 3. So this is nothing but the inverse z transform of p of z is equal to minus half into, what is this? Inverse z transform of z by z minus 1. What is inverse z transform of z by z minus 1? It is equal to 1 plus half times. What is the inverse z transform of z by z minus 3?
3 power n.
It is 3 power n. So this is what? This is our inverse z transform of p of z. So let's take this as 2. Okay, so here it is, see, p of z. We have to find the inverse z transform of this p of z as well as q of z. Inverse z transform of p of z we found out. Now this is pending. We need to find the inverse z transform of z divided by z minus 3 into z minus 1 whole square. Now let's find inverse z transform. Let q of z equal to, what is q of z? Z divided by z minus 1 whole square into z minus 3. This is what we have. Let's take this as q of z. Q of z equal to z by z minus 1 whole square into z minus 3. Next step, what we do is we find q of z divided by z. What is q of z divided by z? It is, if you divide by z on both sides, this z get cancels. Z minus 1 whole square into z minus 3 remains. So q of z divided by z equal to 1 by z minus 1 whole square into z minus 3. So here power 2 is there, that's why I can write it as some other variable will take. We have taken already a and b, so we'll take this as c divided by z minus 1 plus d divided by z minus 1 whole square plus e divided by z minus 3. This is what we take. Okay, so c. Z minus 2 whole square is there. That's why it's c divided by z minus 1 plus d divided by z minus 1 whole square plus e divided by z minus 3. Next, what we do? We multiply by the denominator term, that is z minus 1 whole square into z minus 3 to this entire expression. So when we multiply this to the entire equation, in the first here when we multiply that, denominator and numerator are same, 1 remains. So when you multiply over here, one of the z minus 1 get cancels. What will remain? Z minus 1 into z minus 3 plus d into, when you multiply over here, z minus 1 get cancels. What remains? Z minus 3 remains. So again, the entire expression when you multiply over here, denominator z minus 3 is there. So z minus 3 get cancels. E into z minus 1 whole square. This is what remains. Now next we need to find those constants C, D and E. For that what we shall do? One simple is we can put z equal to 1. That time when you put z equal to 1, this will be 0 and this will be 0. We will get the value of D. So put z equal to 1. 1 equal to this. If you put z equal to 1, 1 minus 1, this will be 0. So C will be 0. Next here D into 1 minus 3. 1 minus 3. Here also this will be 0 if you put z equal to 1. So 1 minus 3 is what? Minus 2. So what will be the value of D? Minus 2D equal to 1. D will be minus 1 by 2. Is it okay everyone?
Yes, ma'am.
Okay, next what we do, we put z equal to 3. If you put z equal to 3, this will be 0 and this will be 0. So you will get the value of E. So we shall put z equal to 3. So 1 equal to, so this will become 0. This also will become 0. E into 3 minus 1 whole square. 3 minus 1 is 2. 2 square is 4. So what is the value of E? 1 by 4. Now next, what shall we do? Equate the coefficient of z square. Is there any coefficient of z square? We have z square, yeah. So you can equate here and here. We have the coefficient of z square, we get it. So equating the coefficient of z square. The coefficient of z square on both sides. Here there is no coefficient of z square, so it is 0. That is equal to, when you multiply these two, z into z, z square, coefficient is c. Then next, d, we do not have any z square term, it's only z. Here when we expand z minus 1 whole square, it's a square minus b, is a square plus b square minus 2ab. So we get z square, coefficient of z square is e. So we get c plus e equal to 0. That implies what is the value of c? Minus e. E is what? 1 by 4. That's why c value will be minus 1 by 4. Is it okay everyone? Equating the coefficient of z square in this expression. On the left hand side there is no z square term, that's why it is 0. Then z into z, z square, coefficient of that is c. Here there is no z square term. Here there is z square term and coefficient is e. So we get c plus e equal to 0. C value will be minus e. E is 1 by 4. That's why it is minus 1 by 4. So we have found c, d, e value. Substitute over here. Substitute in this expression 3. So on substituting we get q of z divided by z, that is equal to, c value is what? Minus 1 by 4 into 1 by z minus 1. D value is minus half into 1 by z minus 1 whole square. Then E value is what? Plus 1 by 4 into 1 by z minus 3. Substitute what is C, D and E. When you substitute C, D and E, what we do next is we find q of z. What is q of z? Minus 1 by 4 into z by z minus 1. Minus half into z by z minus 1 whole square. Plus 1 by 4 into z by z minus 3. Now we shall apply the inverse Laplace transform on both sides. So what happens when you apply inverse z transform? That will be minus 1 by 4 into inverse z transform of z by z minus 1 minus half into inverse z transform of z by z minus 1 whole square plus 1 by 4 into inverse z transform of z by z minus 3. Now tell me, what is this? What is the inverse z transform of z by z minus 1? What is this? Inverse Z transform of Z by Z minus 1. What is it?
1, ma'am.
It's 1. Correct? Inverse Z transform of Z by Z minus 1 is 1. Minus half into. What is this? What is the inverse Z transform of Z by Z minus 1 whole square? This is also a
1 into n.
standard result. It is what?
1 into n.
It is 1 into n, simply n. Then plus 1 by 4 into, what is the inverse Z transform of this?
3 power n.
Yeah, 3 power n. So this is what? Inverse Z transform of Q of Z. Now we need to substitute all these things over here. Where? Over here. This is your main equation. This is your main equation. Y bar of Z equal to P of Z plus Q of Z. So apply inverse Z transform. We have found the inverse Z transform of each of these terms. So inverse Z transform of Y bar of Z equals inverse Z transform of P of Z plus inverse Z transform of Q of Z. Inverse Z transform of P of Z is here. So this is the inverse Z transform of P of Z, minus half plus half into 3 power n, which is minus half plus half into 3 power n. Then inverse Z transform of Q of Z is here. That is minus 1 by 4 minus half into n plus 1 by 4 into 3 power n. You can simplify this and write minus 1 by 3 minus 1 by 4. Is it minus 1 by 3 or half?
Minus 1 by 2, ma'am.
Yeah, it's minus 1 by 2. It's minus 1 by 2 minus 1 by 4. So it is minus 3 by 4. Then we have half 3 power n, 1 by 4 3 power n. So 3 power n is a common term. Half plus 1 by 4 will be 3 by 4 into 3 power n. Then we have minus half into n or n by 2. So this is the solution yn. This is the required solution. Is it okay everybody? Anybody has any doubt? You can clarify. If anybody has any doubt, you can clarify. Okay. Practice only these questions, those who are finding it difficult. Okay. Or else you can work out the questions which are there in the book. In the reference book, you will find many questions. You can work out those questions. Okay. Anybody wants to ask anything on the topic what we have discussed? The main thing what you need to remember in order to solve these equations is the Z transform of un plus 2 or yn plus 2. It is nothing but z square into y bar of z minus y naught minus y1 into z power minus 1. Next, Z transform of yn plus 1, which is nothing but z into y bar of z minus y naught. Then Z transform of yn. What is it? It is y bar of z. Then most of the cases what we use is Z transform of. What is Z transform of z by z minus k? It is k power n. Am I correct? This is inverse Z transform. Inverse Z transform of z by z minus k is k power n. That is Z transform of k power n is z by z minus k. So there are different formulas. Most of the time we use this one. So you need to remember Z transform of k power n is z by z minus k. That's why inverse Z transform of z by z minus k is k power n. In most of the cases we use this formula. You can see in many problems we have used this formula, and only in last few problems we have used a different kind of problems and formulas which we have discussed in the first topic when we were discussing about the standard Z transforms. I have given the list of standard Z transforms. Minimum, like there are only 7 to 8 standard Z transforms are there which you need to remember. Okay, with this the third module we have discussed this at the end. So third module ends. We will begin with the revision from next class. If any questions you all want me to solve, you can send me so that we can solve. I will start from Fourier series. We will begin with Fourier series. If anybody has any questions, we can bring them. Okay. Anything you all want me to ask? Anybody? Anybody wants me to ask anything? Okay. Okay. Thank you, everybody. We'll meet in next class.
Thank you, ma'am.